Hi, I'm Austin Griffith. I've been doing Ethereum development for the better part of a year now, and I've kind of got a tool set that's put together enough that you can kind of quickly build out dApps, and I wanted to demo that today. The two main parts are Clevis and Dapparatus. Clevis is for like orchestration, compiling, deploying contracts. Dapparatus is more for the front end. It's kind of the components that I find that I use all the time, like MetaMask component, a contract loader, events, and I'll get into that in a second. So I wanted to make sure that I started from scratch. Like anybody should be able to follow this along by just spinning up an AWS EC2 instance. The AMI I used was the Ubuntu one. I opened up the correct ports for SSH and Geth and React, made sure you've got 8545 close because that's your RPC. Here's some information on just like setting up your SSH config, and then here's how you provision the box. I also set up an RC local that does Geth sync with RinkB on boot. So then I can just kind of reboot the box and it will come up and start syncing up. And then eventually you'll get to this stage where you're just doing one block at a time. Then I had to do some stuff to get the global install to work, but it's all there, and now you can just do an npm install-g Clevis, and then you can just kind of type Clevis and it's going to run that command. So let's go ahead and clone in an empty repo for the broadcaster. I've just published this article to Medium, and I kind of laid out how I built a simple dApp, and then I'm going to run through those same steps in a screencast to maybe make it more digestible or whatever. So if I jump into that folder and do a Clevis init, this is like going to fire it off. It's going to start downloading all the packages it needs. So it's going to download Clevis, it's going to download Mocha, S3, all sorts of stuff for compiling contracts like Sol-C. It's going to do create React app, so it's going to actually create our front end also. It's going to get into that source code and kind of carve out some stuff that I don't want, like the service worker. And then it's going to plug in some extra templating stuff just to make our life easier as we're building out the dApp. So just to explain Clevis a little bit more, you can head on over to my GitHub, and if you look for Clevis, there's kind of all the commands you can run. Like I said earlier, it's just orchestration. So you can do, it abstracts a lot of the Git and Web3 stuff away. So like signing and recovering, doing a hex or an ASCII, like a lot of stuff that you would do maybe from Web3 or from the Geth console, you can kind of do from Clevis all in one spot. You can do a create of a contract, you can compile a contract, you deploy a contract, explain just kind of explains the interface of the contract, and then you can interface with that contract, like calling functions on the contract and everything. And it's all depending on what RPC node you have. So you could just have Ganache CLI and run like a local testnet, or you can have this thing talking to Robston, Rinkeby, the mainnet, whatever RPC you have set up. Stuff like account stuff, you can say, hey, Clevis, what's the balance of this account? And then it goes on to the React stuff. You can do a build, an upload, and an invalidate, and that actually pushes it to S3 with CloudFront in front of it and deploys the front end. So now we should be ready to go. The most simplistic dApp ever, but we can say npm start. So all we've really run so far is a Clevis init and an npm start, and that's going to bring up the development server. And we should be able to jump to, let's see, what's the IP address of this machine? Just a second. So we should be able to jump to the IP address of this EC2 machine on port 3000, and we should get to our React app. There we go. So we can see that there is MetaMask is already here. It can tell that I'm hooked up to Rinkeby. It's already detecting the injected Web3. Let's maybe even, oh, my dog's having a bad dream. Poor guy. It's okay, bub. So mainnet, we can go to Robston. Oh, I've actually got it set to, it's going to say, hey, switch to Rinkeby. So let's just get back to Rinkeby, and here's the same place you would set, if you were Ganache, you would go to your local 8545. Okay, so basically here's a shell. It's talking to the injected Web3. It's kind of, if I inspect this, I'm going to get the console here, and we could see that anytime there is an update from MetaMask, we get called back the information of the network. Here's the account that it's on, here's the block that we're on, here's your current balance. And all of that is right here in your code in the source in app.js. So here is the entire app right here, right? So we've got the MetaMask component here, we've got the gas component here, and all the gas is doing is just going out to Ether gas station and hitting us up with the current GUI. Yep, 3.414, yeah, okay. And I guess that's probably what this guy's saying too, yeah. Okay, so back to the article. So we started it up, we've got the app. Okay, so it's time to create our first smart contract. Clevis create broadcaster. Whoops, wrong directory. There we go. Clevis create broadcaster. Okay, so that's going to kind of just set up some scaffolding, kind of an empty folder in here called broadcaster. It's going to set up a broadcaster.sol that's totally empty. Arguments, you can pass in what you're going to send to the on deployment. So that's like the constructor, right? Like what you pass into the constructor would be in your arguments.js, and then dependencies. If you're going to use any of the Open Zeppelin stuff, which I should have mentioned comes in it init because I use that so much. But if you want to like use ownable or whatever, that would be right here, and that's where you would do that. But let's go back to the Sol. Let's copy in. So if you go here, you can get the code. Actually, I'll just copy this. Perfect. Boom. Okay, so there's our contract, and all it's going to do is we've got this event called broadcast that has a timestamp and an output, and a function called broadcast that takes in an output, and then basically either on construct or on function call, we're going to emit a broadcast event with a timestamp. Very, very simple, but it's just a good way to demonstrate my tooling. So the next command is probably going to be to compile. So let's Clevis compile the broadcaster. And this is going to use Sol C. It's going to tell you that it's using, what was that, 4.24, something like that. It tells you your version, and here's the output of it. If there's any errors, you'll see those errors here. So now we're compiled. Let's actually go look at what that spits out. So a few other things. There's the ABI, there's the bytecode, and then there's this .compiled. So if I used Zeppelin or some other libraries, this .compiled is going to be the stuff that you send to Etherscan. You know how like when you do the verify, like sign and verify your contract so then other people could see it publicly? This is the stuff that you paste in there, because it's going to compile, like this is just going to be one single text file that can compile to the exact bytecode that you compiled. So I think we're ready to go. Let's see what's next in the to-do. Okay, so there's not any accounts. Actually, there probably is some accounts because I probably created them. Okay, so I've already created them, but in the tutorial I hadn't created any accounts yet. So you do a Clevis new. I'll just do that anyways. Create like a fourth account here and do a Clevis balance of that. Let's see, that would be index 3. So he doesn't have any ETH yet. Let's see if I have any ETH for any of these guys. Nope, doesn't look like it. Okay, so we're going to have to charge up one of these dudes. I bet that's probably going to be the next thing. Yep, okay, so Clevis accounts. And that's going to list. It's the same thing. It's like the ETH.get accounts or whatever. It just kind of, I find myself running the same things the same things over and over, and then I put those into Clevis to make it a little bit easier. But if we go to Rink B and we put in this account, it doesn't have any yet, so I'm just going to send some from my MetaMask. So that is the to address. I'll send 0.1 just so we have plenty of funds to go ahead and start deploying contracts and stuff. So now we're going to be waiting for balance of 0. So we're waiting for that block to get mined. We should also see, ooh, did I do that right? Okay, yeah, so we're just waiting for that block to get mined, and then we should see that the balance should go up here. Cool. What's next in the tutorial? Same thing. Basically, you check the balance. Oh, we got to unlock it too. Unlock 0. Oh wait, gotta have a password. No password. Okay. Oh, it went through, so now we should be able to check the balance of 0. Hooray! We've got 32 US dollars. Now, let's start doing some deployments. Okay, so to deploy a contract, you just do Clevis deploy, the contract name, and then the account that you want to send it from, and boom, we are deploying. Let's go check that transaction on Rinkeby. Oh, let's do this just so we see. Yep, that dude's good. All right, so here goes the transaction. Cool. And there was the demo one. I already talked about the files. I already talked about the Etherscan verify. Explain is kind of cool. So let's see. So once you have your contract compiled, you can do a, what's this project name? Broadcaster. You can do a Clevis explain the broadcaster, and all that's going to do is just give you kind of this nice digestible look at what the ABI spits out. We've got this function called broadcast, we've got a constructor that's not payable, we've got an event that takes in a timestamp and an output. It's just an easy way to interact with, or learn how you can interact with the contract. Okay, so now let's actually interact with the contract, and you can do that right from the command line. So what we're going to do is we're going to say, oh yeah, so the contract did deploy over there. We'd see that it's successfully gone out there. We can click here. Is the code there? Nope. We can verify and publish it. Okay, we might as well do that. It won't take long. Let's grab this. Let's grab that. Here. Broadcaster. And we use 2424. That was our code. I'm not a robot. Oh man, I always fail. Let's try those. Okay, street signs. There we go, and publish. So that should go through, and our contract code should be publicly available for anybody who wants to see it now. Let's jump back to the README. Okay, so now we're actually ready to interact with our contract. So what we're going to do is Clevis contract broadcast. That means, so the format is basically Clevis contract, and then you do the function that you're going to call or send, and then the name of the contract. And then, like, if you're doing a call, if you're doing a get, you can just send that much. But we're going to do a send, so we're actually going to use account 0 to send hello world to the broadcast function of the broadcaster contract. And go. Cool, so now there's a transaction out on Rinkeby that is pending. Oh yeah, and I guess we can see the transactions getting submitted on our Geth node too. Very cool. Okay, so where are we here? There's our, there. Now our code is all nice there, and we can see that it's public, and we can read and write against it if we want to. We can see events, which is going to be kind of cool because we're going to be shipping some events here. Actually, we should see a new event there once it gets caught up. Let's actually read the event from here. So the transaction went through, it should have triggered an event, but I think that's the next step here is to read. Yes, Clevis contract event broadcast. So what we want to do is get all of the broadcast events from the broadcaster, and that should bring us back an array. The first one is contract created, and the second one is hello world. Let's see if Etherscan is picked up on that yet. Yes, there they are. There they both are. There's both of our events. Can we make them look cooler? Hello world and contract created. Totally rad. Awesome. Okay, so what's next in the tutorial? Okay, it looks like it's time to write a test. Okay, so instead of hitting it from the command line, we're going to use the exact same parameters. We're going to say Clevis, broadcast, broadcaster, but we're going to do it in a test, and I have that code available here. Okay, so in our code, let's go look at, here's our whole project. There's a test directory that comes in with Clevis, and there's a clevis.js, and it's kind of like the main orchestrator. Here's like all my Mocha tests, right? What we're going to do is bring in this broadcast right here. So it should broadcast a string and generate an event. And you'll notice that this is exactly like what we did from the command line, but it's in JavaScript in our tests. So it's you kind of play with it from the command line, and you get a feel for how your contract works. You make sure it works the way you think it should, and then you write the tests to prove it works the way it should. And then you can kind of run those tests, not just to test things, but to sort of orchestrate things. Like if I type Clevis test full, it's going to compile my contracts, deploy my contracts, run all my tests, and then inject my like ABI and all the other stuff into my front end, but we'll get to that in a second. So here's our test. We want to run a broadcast, then we want to read back the events, and then we want to make sure that the last event output equals the output string that we sent. Pretty simple stuff. So we need to create a new file called broadcast.js, and all that's going to do, just like this MetaMask, I'll copy it exactly, is it brings in the Clevis library and then calls broadcast. And what are the parameters there? Let's go back to this. Broadcast. It takes in an account index and an output string. That makes sense. I should have just remembered that. So we're going to use account 0, and we're going to say word up jabronis. All right, so now that should be our test, and I can run it. Let's see, let's follow along. Yes, Clevis test broadcast, and broadcast is going to be the name of the file that's there. So you kind of have a file that it becomes the same name as something in your Clevis JSON, but you can do, or JS, but you can do a lot of other stuff in one test, right? You can run all sorts of different ones, but this is a pretty simple example. So we're going to do a Clevis test broadcast, and that should, oh no, we got to unlock our Clevis unlock account 0 with an empty password. There it goes. All right, sweet. So now we kind of have a test that works in line with everything else, and that's pretty handy. So now we can just do we can wire this in to run whenever a full test goes. So a full would be a compile and then a fast, and then the fast is the deploy and a MetaMask and a publish. So we're going to patch in a broadcast here, and we're going to just say test broadcast. So this is kind of cool because it's like calling a Clevis test with Clevis. They can kind of stack up and group together. So if I do a Clevis test full right now, it's going to recompile my contracts, redeploy them to Rinkeby, actually make a broadcast event, make sure, like assert that that event went through correctly, and then I have a MetaMask one that just transfers a little bit to my front end account. It helps for like debugging the front end and how we work on it, and then publish we will get to in a second. I think we're about there. Yeah, Clevis test publish. Okay, publish is interesting. It's going to take what we've spit out in terms of, let's go back to that broadcaster directory. So this is where our smart contract is. This is like the compiled and the bytecode and all that stuff, but now there's also a .address. This is like its address on Rinkeby, and there's also, nope, I think that's it. But all this stuff then needs to be injected into the source code of the React. And we should see that if I go to source and then go to contracts, there it all is. So contracts is going to be a list of all the contracts I've created so far. If I do a Clevis create and a new one, it's going to get added in here, and then it'll sync across when I do the publish. There's my bytecode, there's my block number, there's the address and the ABI. So the front end is ready to talk to the contract that we just deployed. Let's dive into that. It's time to bring in some Dapparatus components. So if I go back to my GitHub, here's Dapparatus. It's components, it's React components. So there's a MetaMask, a gas, a transactions, a contract loader, events, and a scalar for visual stuff. And we'll kind of cover those as we add them in. So it looks like the first thing to do is to bring in a contract loader. So I'm just going to go copy that from, right from the GitHub. And let's get to editing our, let's go ahead and save that. Let's do another test just to make sure I didn't break anything. Okay, so we're going to do another broadcast there. Okay, so let's talk about editing our front end. Let's say our contracts, our back end is ready to go. It's already deployed. We can go talk to our contracts from the command line. We can talk to them from our tests. Now it's time to talk to them from the front end. So your app.js is right here. We've got the gas and the MetaMask already up and running, and we see it here. We can do that inspect, and we can see that gas and MetaMask already happening. So now it's time for the contract loader. Hopefully I still have him. So this is the connected display. Okay, so right here in the connected display, I'm going to bring in the contract loader. Cool. And let's save that out there and watch what comes back from the console. Boom. Okay, so the contract loader has loaded the contract broadcaster. And if we get into that, it's the .methods of a contract, but you can get back to the contract if you want to get into it deeper. But we see here's the address, here's the block number, and here are the actual functions I can call on it, right? There's a broadcast function that takes a string. So when I want to start interacting with the contract, that's where I will do it. Now let's fire up, whoa, we're steps ahead of that. Okay, looking at the console, we've already seen the MetaMask, we've already seen the gas, we've already seen the contracts. We are ahead of schedule. Okay, transactions is next. So let's jump back to the Dapparatus stuff. Let's grab the transactions component. Cool. And he will go in here too. All right, and let's save that. So the transactions component has this onReady hook that then sets up the state of the main app. And one thing it does that's pretty important is it creates this TX function. And the TX function is used to wrap all of your transactions. And you do that because you want like a lot of other state changes and stuff to come from those transactions. And then the transactions, the TX function gives you like this just really nice callback, and it does all the receipt watching and stuff for you. So what does our front end look like now? Check it out. We've got block numbers now. So by adding in the transactions component, we've got this like these progress bars down in the bottom right, and it shows what progress the current block is on, and it's trying to like keep track of like what the average block number is and trying to do a good job of like estimating when that's going to be. But when we send a transaction, we'll also see those here, and you'll see this exact same UI in like all my games and all my dapps, just because I just bring it in and it's there and I don't have to worry about it. So let's see. Oh, let's go look back at the console. We're going to get a little, transaction component is ready, and that's where this TX function comes in. And what's next? Okay, we're going to bring in a few other components, and we're going to create a little UI. And I think I'm going to try to just copy those from the demo from the write-up. I think that's right here. Okay, cool. And also, so in my front end right now, I sort of have just this connected display, and that comes up once you have Web3. What we're going to do is create a new display that's going to be called contracts display, and that's going to trigger once the contracts come in from once the contracts get loaded. And that will go. Let's just copy all of this in from the demo. Hopefully I'm grabbing it right. There we go. So once we have Web3, then we want to say, do we have contracts? And if we have the contracts, we're going to bring in another Dapparatus object called address. Oh man, I don't even have it in the documentation yet. Whew, someone needs to update their documentation. I'll go do that after I get done with this. But the address brings in a nice little kind of like, it shows the little identicon blocky thing, shows the address, it makes it linkable so you can go to Etherscan, and then it shows how much ETH is in that address. So just a nice little object. Every time I have an address in any of my dApps, I can just throw this address in there, and it kind of gives that extra functionality. Same thing with address. I've got button. Button is another component that probably isn't in the docs that I will add after this, but that brings in a nice little MetaMask looking button, right? Like the green and the yellow. So he also has an on click, and I bet that's what we'll get to here. Yeah, so here is the UI that we're trying to build. Kind of here's that address. We're going to take in a broadcast string and have a little button there. So a lot of this stuff is just kind of pre-built with Dapparatus, and let's not bring in the events yet. And I've got the scaler already there. We're kind of getting ahead of ourselves a little bit, but I'll try to navigate that as we get there. So let's take out the events. Heck, let's take out the scaler too. Too far ahead of it. Okay, so all we've done is just add in an address. We've added in the input box, and we've added in the button. So when we go to our front end, hopefully we see that, or some kind of an error. Oh, broadcast text isn't part of our state. We need to remember to go up to our React state and have some kind of blank broadcast text. How we do now? Ooh, something else is wrong. Oh, there's no handle input. I'm going to steal that from, all you do is just look for, you look at the event. Here we go. Boom. So anytime someone types in that text box, you want that to update the state. That's right here. It says, hey, whatever the target name is, update the value of that in the state. And then as long as you have name equal to the value there, then your text box should stay up to date and it should stay in the state. Let's see how we did. Okay, there we go. Oh, it's not drawing yet. We need to take contract display and actually show it. Oh, cool. Okay, there we go. So there is the, what is that? Is that the address of the contract? It is. So that's the address of the contract. There's no ETH in it. And it's saying, hey, you want to broadcast a string, and let's see, it is. So it's tracking the input. That's good. And our send button, let's wire that up now. Actually, I already have, but I bet that's the next thing that I talk about here. Yeah, okay, wiring up the broadcast. So once you've got your button in there, you're going to want to tell it what to do on click, and that's this stuff right here. So let's see, we're probably going to want to have the button like change color, and it does automatically. So when you click a Dapparatus button, it immediately goes gray for a little bit just to let you know that you've like done something. But let's say we're building blockchain UI here, which is always kind of a trick, but it's not going to just broadcast the event right away, right? We're gonna have to wait for the block to get mined. So let's say you click the button, it turns gray, but then we want to wait until we actually get a receipt back from that transaction before we let them know that it like went through. So what we'll do is we'll just say some kind of doing transaction equals true, and then we'll do our stuff, and then we'll say doing transaction equals false. And then we can kind of like color the button or whatever based on whether or not we're doing a transaction. Okay, so let's actually talk about the transaction. Here it is right here. And this is very similar to like what we were doing from the command line. We said we want to run the broadcast function on the broadcaster smart contract, and we want to pass it the argument of our broadcast text. So that's all accessible right in your contracts object, and that came in from the contract loader. All we had to do with the contract loader is say, boom, we just bring in that object, and the contracts are just all part of the state now. And those contracts are all injected from Clevis, so we don't do anything special there. We just had to make sure Clevis was there, and we did a publish. So that brings it all the way into our front end and makes it a lot easier to work with. So let's see what else. So let's look at this little piece right here, right? TX. So TX is the transaction object that got passed in from this transactions component where it does a set state here. It's setting that transaction. And what that is just a wrapper for our function. So we want to call broadcast on the broadcaster, and we're going to pass that in as the first argument to the TX function. And then so there's a couple other arguments you can do. Check out the documentation when I actually update it and it's there. But I think the second argument can be, I think, max gas limit. And the third argument can be extra data that you want to go in through the transaction. And then the fourth argument can be the callback, but then it's doing the usual, like, look to see if any of these arguments are functions, and if they are, consider that the callback. So I'm just passing in just the broadcast, and then I'm going to pass this in to say once the transaction is finished and we have a receipt from it, from the blockchain, and we know it's good, then call back to me with that receipt. And that's when I'll do the thing where I change the button color back, and I'll clear the text out of the box. So there we go. I think our UI is basically ready to go. Let's find out if it works. So what should we say? I'm talking to the blockchain. And send, and it brings up a MetaMask notification, and it's going to cost us 3 cents. And we click confirm. Now watch down in the bottom right when I click confirm here. Boom. So this new thing. So here's the thing, the block loader, but this is the transaction loader. And if I click that, it's the transaction that's currently going through in React. And notice our button is orange and our text is still here. We're kind of waiting for this transaction to happen. This is a very tricky piece of building a dApp. You got to give really smooth user interface to a backend process that's not at all smooth. And this is on Rinkeby, so it'll be a little bit quicker, but this transaction could take minutes, right? Or it could take 3 seconds. You don't know how long this transaction, and so I think this will be really neat to see how this evolves over the next year, how dApp developers kind of compensate for this time that the user has to wait. Like right now, this transaction is taking longer than it even thinks it should. This is going to turn yellow in a little bit. Like this is a good demonstration of how blockchain UI is hard. We're still waiting for that to be broadcast. And we could, oh, there it goes. It just turned green. Send just turned green. That's good. So I bet if we were to go look in our console, we got a nice receipt back. It's in there somewhere. Oh no, I didn't even console log the receipt, so it's not there. But it went. And we could go look at, let's go look at the contract event. Let's see if I'm talking to the blockchain is here yet. Will it be the top one? Yep, there it is. I'm talking to the blockchain. Freaking rad. Okay, so what else? Events, right? If you're going to have a dApp that's talking to the chain, it's probably also going to want to read back from the chain. So let's start parsing these events, right? We can go here and see the events here, but we actually want to display it to our users, right? Okay, so let's go grab that events thing. I think I pulled it out. Let's put it back in here. And you'll see in the Dapparatus documentation that we can do config hide equals false. So normally most of these things are hidden. A lot of these components are kind of like silent components that wire up some stuff and can give you some stuff back. They're React components because everything else that you're going to build is going to need to be like this nice visual component. But we're going to actually say hide false, and we're just going to kind of like raw show the events. So again, like we just copy and pasted this right from the Dapparatus documentation, and we hit save. We're going to change the event name to broadcast and the contract to broadcaster, but that's all we have to do. And then boom, there are our broadcasts. And if you're wondering, these are just objects that we could display this in a much prettier way in about 2 minutes, right? So it's just these events, and we can say like event map. Let's just do it. Okay, so let's say let's call something called event display equals nothing, and then we'll say if this.state.events, then we're going to go ahead and go here, and then we'll just do this.state.events with two P's. I'm leaving the misspell. We're going with it. Equals this dot map, and inside of that it will be taking some event E, and we will return some prettier thing like a div that says, hey, I'm an event, and I'm going to say E dot, what do we have here? We've got a timestamp and an output. Let's just do E dot output. And then let's just go ahead and display the events below my normal thing. What are the chances? Please work first try. It did not. What'd I do wrong there? Return the event, fit.output. I don't know. Am I getting an error? Now it really broke it. Okay, can't read map of undefined. Okay, whatever. Bad demo. But basically your events are part of your state, and you can draw whatever React component you want. So what is left? Okay, so you can't watch this as we scale this. Actually, let me go back to the write-up. I'm pretty sure the scaler is next. Yep, it is. Okay, so we're almost done. Our DApp is working pretty well. But if I scale this down, if I crunch this down, or if I go visit this on my phone, it's going to look pretty bad. So you'll notice that my MetaMask component and my block loader, they scale. But this stuff, the other stuff that I've just built, kind of crushes. So what we want to do is add one other thing, and it's just the scaler. And it's just one tag that kind of goes out around. So if you have like position absolute or position fixed things, your scaler can't be out around that. It's got to be in that farther. But once you've got your position absolute and you've got your thing placed, then the content inside of that you can wrap in a scaler, and the scaler can take like kind of what scale you want it to go, whether you want them to be a little bit bigger. But what it's doing is just looking at the screen width and figuring out how to kind of like make things fit a little bit better. I don't know if that's obvious what we did there, but this looks a lot better on a mobile phone now than this would. Let's look at that same thing. See that how that it's kind of like crushed up. I don't know. It's kind of like subjective stuff. You just want to make sure that your app is usable for someone. So I think we're almost done here. Oh, okay. So this is ready to go, right? So if I wanted to deploy this to my S3 or to IPFS or something, I've got basically a static site built. I just have to do a Clevis build, and that's going to build the static site into something that can be deployed to any static site host. And from there I can do Clevis upload and then my site, and I'll have to have AWS credentials in here, and then Clevis invalidate, and that kind of clears the cache from CloudFront. But that's basically my whole start to finish process for building a dApp. And there's a ton of reusable components that anybody can take and please reuse and please make them better. And hit me up with feedback. Hit me up on Twitter. Learn more about me at austingriffith.com. Thank you very much for checking this out. I hope it's useful to you. I hope it's something that could be built upon. Thank you.